So as I said, in this electromagnetics, vector analysis is very important, no? Because you will then understand how an electric field, you will understand the electromagnetic field and electric field and other phenomena, no? The application of this subject. So let's try to solve 8 common problems. So this is the first one. Okay, given points M, so with a coordinate with the coordinates negative 1, 2, and 1, and then also point N and point P. Find the RMN, or this is the vector from M to N. Okay, take note of the direction from M to N. Okay, and then the other one is sorry, I think this one is okay, the addition of two vectors. Okay, and then you have the absolute, or we call this one the magnitude, or the unit, the magnitude of the vector M. Okay, and then you have the AMP from M to P, and then you have the sum of the vector operation. Okay, so okay, the good thing with this, you can actually plot them. Okay, you can plot them so that you will understand how the vector is placed, no? The placement of the displacement of the vectors. Okay, so for example, you have negative 1 and 2. So you have so x. So most of the time, so we have this drawing. Okay, negative 1. So we assume x here, y, and z. Actually, you can interchange. Okay, no problem if you interchange the x, y, z, as long as you are consistent. So this is negative 1, then 2. So actually, if you know already what you're doing, so you don't need to draw actually, no? So the important thing is you just you know y, no? So this is the point M. Okay, so given the coordinate 2, negative 1, and then 1 for the z. So this is the point M. And then we have the point N when it is positive 3, 1, 2, 3 in the x, and then negative 3 to the y, 1, 2, 3. Okay, so here, and then 0. So the along z axis, so 0. So you just put here. Okay, so that's N. And then P, so you have negative 2, then negative 3. Okay, at this point, and then negative 4. So 4 downward. So 4 steps downward. 1, 2, 3, 4. Okay, so this is your P. Okay, now RMN is the vector from M to N. So let's label this one first. Let's label this with this is M, this is N, this is P. Okay, very simple. RMN is actually from this one, the vector from M to N. Okay, what is that vector? Okay, and then the other one, letter B, is the addition of two vectors. Okay, so RMN plus MP. Okay, so you add the two vectors. So this is the MP. Okay, so this is the RMP, and this is the RMN. Okay, so first we solve for the RMN. So for the RMN, we can do is now this one doesn't tells us whether rectangular, cylindrical, or spherical, but since this is a the basic one, so this is, we can solve it in a rectangular, any form. Okay, regardless, any form. So vector is by default, or I mean most of the time, we use the rectangular or Cartesian coordinate system. Okay, so very simple. It's actually the vector RMN is actually the subtraction of 2 points, no? Okay, so it's actually like this. You have the point M, the vector M, Okay, so we represent this one with a vector m. So this is negative 1, 2, and 1. And then subtract the vector of n. Okay. Sorry, I made a mistake. It should be the final minus the initial. So the final is n. So this is n, and this is m. Okay, so you have 3, negative 3, 0, then negative 1, 2, and 1. Okay, so this one is just a representation of a vector. Okay, so when we apply the rectangular or Cartesian coordinate form, so what we can do is 3 minus the negative of 1. Okay, minus the negative of 1. Okay, so this is in the along x, no? So this is ax. Okay, plus negative 3 minus 2, the one along y, plus 0 minus 1 along z. Okay, so that's it. So and then we just simply subtract them. So we have 4ax, then negative 3 minus 2 is negative 5 ay minus az. Okay, so that is your RMN. Okay, so this is for your letter A. Or this is the Cartesian coordinate system. You can also represent this one as this one. Okay, this is 4 negative 5 or negative 1. Okay, so we use this format sometimes, but this one is already an answer. Okay, so you can depends on sometimes they use the ijk instead of ax, ay, and az. Okay, so letter B, so this is A. Okay, letter B is we need to get the MP first, no? We need to get the MP. So the vector MP, so which is before we can add RMN and RMP. Okay, so RMP, how do you solve the RMP? So we have from M to P. So therefore this is P minus M. So we can go directly. So you write the P, the AX of P. So this is negative 2 minus the M, negative 1. Okay, the X along M, or the X coordinate. So okay, so this one is AX. Okay, so I hope you understand the physical meaning. It's simply stating you that this is the distance between M and P, okay, with respect to X. Okay, and then now if you ask why is it what if negative 1 minus negative 2? Okay, is it correct? No, because the vector is a direction dependent, no? So the direction is very important. So if this is RPM, okay, then that should be negative 1 minus negative 2, okay, because the arrow is pointing to P. So therefore P is the final destination, M is the initial position. So you need to subtract final minus the initial. Okay, and then so we have the AY. So AY is negative 3 in the point coordinate P, and then in M is 2 minus 2. This is AY, and then plus AZ. So you have negative 4 minus 1. Okay, so this is AZ. Okay, and then you just simply operate the basic operation. So you have negative 2 plus 1, so this is negative AX or negative 1 AX, and then plus or minus 5 AY, and then this sorry, I think we made it's correct, no? Yeah, 1 2 1 1 2 1 3 negative. Okay, that's correct. And then we have negative 4, so negative 5 AZ. Okay, then we have the operation. So RMN plus plus RMP. Okay, so it's how do you add two vectors? Add both the we just add all the common similar terms, no? So if it is in terms of AX, you just add the AX. In terms of AY, you just add in AY. Okay, so very simple. Given this RMN and then the RMP, you just add all the value there. So you have 4AX minus AX. So this is, okay, I will just 4 minus 1 AX. Okay. Then we have negative 5 for RMN. Actually, plus negative 5. Okay. And plus negative 5. So that's negative 5. Okay. AY. And then negative 1 RMN plus negative 5. So that is, okay, I will write plus. So you have plus negative 1 minus 5. Okay, so very simple. You have 3AX minus 10 AY minus 6 AZ. Okay. Okay, so we got it right. And so we go now to the RM. Okay, so letter C. So we got it right. And then C. Okay, how do you solve for C? The magnitude of RM. Okay, now this RM is actually it's not RMN. Okay, so this RM is a vector. We call this one the directional vector, or I mean the vector from origin to M. Okay, so if only one point, okay, in this case RM, sorry, this is only RM. So this is the vector from M, from 0 to M. Okay, so we write, so that is why we can directly write, actually this is, okay, so this is vector M. So we write vector negative 1, 2, and 1. Okay, minus, this is because the final destination is M. So minus the initial, which is origin, which is 0. Okay, it's clear, no? So therefore your RM is equal to negative 1 minus 0 is obviously, no? You have negative AX plus 2 AY plus 1 AZ, or AZ. You may not need to write 1. Okay, so so this is plus. Now when you have a magnitude, okay, how do you solve the magnitude of a vector? Okay, how to get the magnitude of the vector is to get the root mean square of the vector. Okay, RMS. Okay, the root mean square is like the Pythagorean if you only have 2 dimension. Okay, but the magnitude of RM is equal to the square root of negative 1. Okay, the magnitude along x, which is negative 1, plus 2 squared plus 1 squared. Okay, so this is 1 plus 4 plus 1, so this is square root of 6. Is it? Square root of 6. Okay? Or this should be equal to 2.45. Square root of 6 is equal. Okay, so that's it. Or square root 2.45. Okay, so let's proceed to D. Now, what is AMP? Now, the AMP here is a unit vector from M to P. Okay, we discussed last meeting about the unit vector. Unit vector is simply actually the can be u or a, small a or small u, but this case we use a. Okay, so AMP is the vector from MP, so RMP, okay, divided by the magnitude of the vector RMP. Okay, okay, so you have, what is the vector RMP? So we already solved it in problem B. So you have negative AX minus 5AY minus 5AZ. Okay, divided by the magnitude. So how do you get the magnitude? Just take the RMS value. Okay, so that's square root of negative 1 squared plus negative 5 squared plus negative 5 squared. Okay, so this is 25 plus 25, 50, 51. Okay, the square root of 51. So so therefore this is equal to, so if you try to divide, okay, so square root of 51 is equal to 7.4. So or 1. So this is the first one is negative. Actually, you can just write negative 1 over square root of 51 AX, and then minus 5 over square root of 51 AY minus 5 over square root of 51 AZ. Okay, this is the answer already. But if the problem is asking for the decimal numerical equivalent, then you need to use your calculator. Okay, so the first one is actually negative 0.14. Okay, you can express this one you can express this in numerical value. Okay, I think it will not be difficult. Okay, and then the last problem we have the magnitude of the difference between RP and RN. With this one is a basic operation. Okay, so first we need to solve for 2RP and then 2RN. We already know how to get RP. Okay, it's a vector from origin to the point P, and then Rn is the origin to point N. So you just get the vector, and it's like similar to problem C. Okay, so we can directly solve for 2RP. Okay, you just write 2RP. 2RP is 2 times the RP. So the RP here is the point P. So we have negative 2AX minus 3AY minus 4AZ. Okay, I hope you know already that it's not directly because it's not because the P has this coordinate, but because we know that it's from origin to P. So negative 2 minus 0 is negative 2, negative 3 minus 0 is negative 3. Okay, then you just multiply by 2. Then we have that 3Rn. Okay, so you have 3 times the Rn. So we have 3AX minus 3AY. Okay, so we have no 0. So you just leave the AZ 0 or, okay. So we have this. So here we have for A1, so you have negative 4AX minus 6AY minus 8AZ. Okay, for Rn, so you have 9AX minus 9AY. And then the next step is we do the operation subtraction between 2RP and 3Rn. Okay, so this follows the we call this one the PM dash, no? Parenthesis, multiplication, division, addition, subtraction in basic operation of math, no? PM dash. So okay, so that's it. So we done first the multiplication, and then that's the next one is subtraction. Okay, so the subtraction between 2RP minus 3Rn. Okay, so we have So we subtract only with respect to their axis, no? We cannot subtract -4 with the AY, no? -9. Okay? So therefore we have -4 for the RP, and then minus the one in the RN, so which is 9. Okay, so you have AX, and then plus, okay, the subtraction or the difference between -6 and then -9, so that's negative minus 9, so that's positive 9. Okay, the double negation is becomes positive. Okay, and then AZ, plus -8, and then minus 0, so you just write maybe you can write 0 then AZ. Okay, so there you just do the operation there. So -4 minus 9 is -13 AX, so plus 3 AY, minus 8 AZ. Okay, now we're not yet done because the problem is asking for the magnitude of this operation. So to get the magnitude of this operation, okay, so we just need to do the simple operation on this. So we have we have square root of -13 squared plus 3 squared plus -8 to the square. Okay, in this case you can use our calculator. So we have 13 squared plus 3 squared plus 8 squared. So you have 11 over square root of 2, or should be 15.56. Okay, and this is 15.56. Okay, so that's it. So this is for the first problem. So